Find the coordinates of center and foci, equations to directrices and latus rectum of the ellipse given by the equation 9x square plus 25y square minus 18x minus 100y minus 116 equals 0. We will rewrite this equation of ellipse to the form x minus h the whole square divided by a square plus y minus k the whole square divided by b square equals 1. For that, we will rewrite this equation as perfect squares of the form x minus h the whole square and y minus k the whole square. In the LHS, we will group terms containing x and y separately. We have terms containing x are 9x square and negative 18x. Terms containing y are 25y square and negative 100y. The constant term negative 116 in the LHS can be taken to RHS. If you add 9 along with these terms 9x square minus 18x, then we have this term rewritten as 9 times x square minus 2x plus 1, which can be written as 9 times x minus 1 the whole square. Therefore, in order to obtain a perfect square term of the form x minus h the whole square, we will add 9 on both sides. Similarly, in order to get perfect square of the form y minus k the whole square, we will add 100 on both sides of the equation, so that we have 25y square minus 100y plus 100 rewritten as 25 times y square minus 4y plus 4, which can be written as 25 times y minus 2 the whole square. On adding 100 and 9 to the RHS, we will have 109 added to RHS. Thus, our RHS become 116 plus 109, which is 225. When you divide both sides of this equation using 225, you have the RHS becoming 1 and LHS become x minus 1 the whole square divided by 25 plus y minus 2 the whole square divided by 9. Since we have 9 by 225 equals 1 by 25 and 25 by 225 equals 1 by 9. By means of transformation equations, capital X equals x minus 1 and capital Y equals y minus 2, this equation of ellipse can be rewritten as capital X square divided by 25 plus capital Y square divided by 9 equals 1. By doing so, we have transformed from the original axis small x small y to a new axis capital X capital Y. We will evaluate center, foci, directrices and length of latus rectum for this ellipse with respect to axis capital X capital Y. We have this equation of ellipse will have center 0 0, foci will be plus minus AE 0, where A equals 5 and E can be evaluated using the formula E equals root of A square minus B square upon A, from which we have E equals root of 25 minus 9 divided by 5, which becomes 45. Having found A and E, we have plus minus AE equals plus minus 5 times 4 by 5, which becomes 4. Thus, foci is obtained as plus minus 4 0. We have for this ellipse, equation of directrices will be capital X equals plus minus A by E, where A equals 5 and E equals 4 by 5. We have plus minus A by E equals plus minus 5 divided by 4 by 5, which becomes plus minus 25 by 4. That is, equation of directrice will be capital X equals plus minus 25 by 4. We have length of latus rectum, which is independent of any choice of axis, will be length equals 2b square by a, where b square equals 9 and a equals 5. Therefore, length of latus rectum will be 2 times 9 divided by a, which is 18 by 5, which is 3.6. By means of these transformation equations, we will now find out center, foci, equation of directrices with respect to original axis small x small y, which will be center, foci, equation of directrices corresponding to this equation of ellipse. We have small x equals capital X plus 1 from the transformation equation. Since center of ellipse with respect to new axis capital X capital Y was evaluated as center with coordinates 0 0, we have capital X equals 0 and capital Y equals 0. Thus we have small x equals 0 plus 1, which is 1, and small y equals 0 plus 2, which is 2. Thus, with respect to original axis, our ellipse has center 1 2. Since we have found foci with respect to new axis capital X capital Y was plus minus 4 0, where capital X takes two values positive 4 as well as negative 4, and capital Y equals 0. We have small x equals capital X plus 1, which is 4 plus 1, which is 5. Small y equals capital Y plus 2, which is 0 plus 2, which is 2, which will give us one of the foci with coordinates 5, 2. Small x equals minus 4 plus 1 will give us minus 3, and y remains the same, y equals 2. Thus we have the other foci with coordinates minus 3, 2. With respect to new axis capital X capital Y, we had evaluated equation of direct traces as capital X equals plus minus 25 by 4. Therefore, we have with respect to original axis small x small y, equation of direct traces will be small x equals capital X plus 1, which implies small x minus 1 equals capital X, where capital X takes the values plus or minus 25 by 4. This equation can be rewritten as 4x minus 4 equals plus or minus 25. Thus we get two set of equations, 4x minus 29 equals 0 and 4x plus 21 equals 0, which are the equations of direct traces with respect to original axis small x small y. Length of lattice rectangle will be the same since it is independent of choice of axis, and hence we have length of lattice rectum equals 3.6.